A dwarf planet 4 billion miles away just got read like an open book, without a single spacecraft ever going back to visit it. And the tool that pulled this off wasn't even designed with Pluto as its main target. Nobody expected it to work this well. Stick around, because I'm about to walk you through exactly what James Webb just confirmed about Pluto and why scientists spent years assuming this specific measurement simply couldn't be done. And hit subscribe now, because this channel breaks down real space discoveries without the exaggeration, and you do not want to miss what else is coming out of the outer solar system. Let's go back to where this story actually begins, because Pluto's history is stranger than most people remember. In 1930, a 24-year-old assistant named Clyde Tombaugh, working at an observatory outside Flagstaff, Arizona, was given one of the most tedious jobs imaginable. He photographed the same patch of night sky on different nights, then flipped back and forth between the plates, searching for a single point of light that had shifted position. Most nights produced nothing at all. Then, on one plate in February of that year, something moved. A tiny dot had shifted against a background of fixed stars, and that dot became Pluto. For the better part of a century afterward, it held the title of the 9th planet in our solar system, even though it was so distant and so small that astronomers could only guess at what it actually looked like up close. Then in 2006, the International Astronomical Union held a vote and formally reclassified Pluto as a dwarf planet, stripping it of the title that had made it famous. It remains the only world in recorded astronomical history to be discovered, celebrated, and then formally voted out of the very category that once defined it. For a long time, that felt like the end of the story. Pluto was small, distant, and easy to file away as unimportant. That assumption did not survive contact with real data. It is worth pausing on just how little we actually knew about Pluto before any spacecraft ever visited it. For most of the 20th century, even the largest, telescopes on Earth could only resolve Pluto as a tiny, blurry smudge of light. Astronomers could estimate its orbit fairly precisely, since that only required tracking its position over time, but its size, its surface composition, and whether it even had an atmosphere at all remained genuinely open questions for decades. In July of 2015, after a journey lasting 9.5 years across billions of miles of empty space, NASA's New Horizons spacecraft flew past Pluto at more than 30,000 miles per hour. It had exactly one chance. No orbit, no second pass, just a narrow window of a few minutes to capture as much as it possibly could before continuing on into the darkness of the Kuiper Belt forever. What it sent back completely rewired what scientists thought they knew. A massive, pale, heart-shaped plane stretched across the surface, smooth and strangely young-looking compared to the ancient, heavily cratered terrain surrounding it. Mountains built from solid water ice rose more than 10,000 feet into a thin, hazy sky, frozen so hard at those temperatures that it behaved less like ice and more like solid rock. Fields of nitrogen ice appeared to be slowly churning in giant convection patterns, hinting at heat and motion happening beneath a crust that scientists had assumed was completely dead. And layer after layer of blue haze rose hundreds of miles above the surface, visible even when backlit by the sun. But New Horizons only got one look. It captured what it captured and kept flying deeper into the outer solar system, never to return. Whatever it missed on that single pass would remain a mystery for years. What researchers needed wasn't a better photograph. They needed a way to read Pluto's chemistry directly from millions of miles away, without ever sending another spacecraft. That is exactly what the James Webb Space Telescope was eventually able to do. And here is the part that shouldn't have worked. Webb does not fly past anything and snap a G it apart into its individual wavelengths to reveal the precise chemical fingerprint of whatever it happens to be staring at. Pointed at a faint pinprick of reflected sunlight billions of miles away, it can tell researchers what molecules are present, how warm different layers of an atmosphere actually are, and how that atmosphere is behaving over time, all without physically traveling anywhere. The technical challenge involved here is worth appreciating on its own. Pluto and its largest moon Charon sit so close together in the sky from Webb's point of view that separating their individual thermal signals used to be practically impossible with earlier generations of telescopes. Researchers working before Webb launched had repeatedly tried to detect specific heat signatures around Pluto and repeatedly came up empty, not because the signal didn't exist, but because their instruments simply could not tell how much of the detected heat was coming from Pluto itself, and how much was bleeding in from Charon sitting nearby. Webb's much larger mirror and far more sensitive infrared instruments finally solved that specific problem, allowing scientists to cleanly isolate Pluto's own thermal signature for the first time in the telescope's history. Starting in 2022, once its instruments were fully calibrated, Webb turned its attention toward Pluto. And what has come back in the years since hasn't simply been a prettier picture. It has been closer to a full diagnosis, revealing a set of behaviors so unusual that researchers are still working out exactly how to explain some of them. if you are the kind of person who wants space stories explained clearly instead of buried. Under jargon, go ahead and drop a like on this video right now, because it genuinely helps this kind of content reach more people who would enjoy it. The first major finding involves that same blue haze New Horizons, first photographed back in 2015. Researchers already knew Pluto's thin atmosphere was wrapped in a delicate shroud of hydrocarbon particles, but what nobody had confirmed was exactly what that haze was doing to the world underneath it. Back in 2017, a planetary scientist named Xi Zhang, working at the University of California, Santa Cruz, proposed an idea that sounded almost backwards at the time. On Saturn's moon, Titan atmospheric haze traps heat and warms the world below it. Zhang argued that Pluto's haze might be doing the exact opposite, absorbing sunlight during the day and then radiating that energy straight back out into space as infrared heat faster than Pluto's extremely thin atmosphere could ever hold onto it. In effect, the haze would not be acting like a blanket. It would be acting like a radiator, actively bleeding heat away from a world that already had almost none to spare. At the time, this idea struck many of Zhang's peers as unlikely, and there was no instrument available, yet capable of actually testing it. That changed once Webb's mid-infrared instrument became sensitive enough to separate Pluto's faint thermal signal from that of Charon, something earlier telescopes had never been able to do cleanly. A team led by astronomer Tanguy Bertrand at the Paris Observatory used that instrument to measure Pluto's atmosphere directly, and the results, published in the journal Nature Astronomy in June 2025, confirmed almost exactly what Zhang had predicted 8 years earlier. Pluto's upper atmosphere really is being actively cooled by the very haze particles suspended within it, and it turned out to be roughly 30 degrees Fahrenheit colder than earlier models had expected. Researchers now describe this as a genuinely new kind of climate, one that behaves differently from every other atmosphere studied anywhere else in the solar system. Pluto isn't simply cold because it sits so far from the sun. In a very real sense, Pluto appears to be actively refrigerating itself, and scientists are still working out how far the consequences of that discovery actually reach, including whether similar hazes might be quietly shaping the climates of other distant hazy worlds like Neptune's moon Triton. There's a second discovery tied to that same haze, and it's quieter, but honestly just as strange once you sit with it. Even the extremely faint trickle of sunlight that reaches Pluto is enough to break apart methane molecules high up in its atmosphere. Those broken fragments don't simply vanish, they recombine into heavier compounds, forming a slow chemical cascade that eventually produces reddish-brown particles known as tholins, which drift downward and settle onto the surface below. New Horizons caught early traces of this chemical process back in 2015, and more recent observations have continued to refine exactly how it unfolds. Here's the detail that tends to stop people in their tracks. Tholins belong to the same broad family of organic molecules that some scientists believe may have once rained down onto early Earth, potentially contributing RAW material for the kind of chemistry that eventually led to life here. On Pluto, that same basic process has apparently been running for roughly 4 billion years, a slow, continuous snowfall of biological building blocks, landing on a surface that is simply too frozen for any of it to ever spark into something alive. To really understand how extreme that cold actually is, it helps to look at the raw numbers. Sunlight reaching Pluto is roughly 1,000 times fainter than sunlight reaching Earth, meaning even high noon there would look closer to a heavy twilight here. Surface temperatures generally sit somewhere between about negative 308 I7 and negative 369 degrees Fahrenheit, more than 250 degrees colder than the coldest temperature ever recorded anywhere on Earth. At those kinds of temperatures, nitrogen, the same gas that makes up most of the air you're breathing right now, freezes completely solid. The third major finding is the one that tends to unsettle people the most once they hear it explained properly. Pluto has been slowly leaking into space for billions of years. Methane and other light molecules drift upward through its thin atmosphere, slip past its weak gravity, and escape outward. Scientists already suspected this was happening, but for a long time, nobody knew exactly where all of that escaping material was actually going. Pluto's largest companion, a battered ice moon named Charon, roughly 750 miles across, orbits in an extremely tight gravitational partnership with Pluto. Most of Charon's surface is fairly unremarkable water ice, except at its poles, which are stained a deep, unmistakable reddish-brown, darker than anything else visible on the moon. The mechanism behind this turns out to be tied closely to Charon's extremely slow, extremely long seasons. Because of the way Charon is tilted as it orbits alongside Pluto, its northern polar region spends multiple decades in complete darkness at a time. That makes the pole an extremely effective cold trap, a place where escaping methane molecules drift in, freeze solid onto the surface, and sit there accumulating for years before sunlight finally returns. Once sunlight does return, ultraviolet radiation and cosmic rays break the frozen molecules apart and reassemble the fragments into heavier reddish compounds, essentially locking in that dark coloring permanently. Karen had one more surprise waiting too. In October 2024, a team led by researcher Sylvia Protopapa at the Southwest Research Institute used Webb data to confirm the presence of both carbon dioxide and hydrogen peroxide frozen directly onto Karen's surface. According to the published research, the carbon dioxide most likely originated from underground material, exposed by impact craters, while the hydrogen peroxide appears to have formed through years of radiation striking Karen's water ice and rearranging it into something new. If you found this as strange and fascinating as I did while researching it, drop a comment letting me know, because it genuinely helps me figure out what other space stories are worth covering next. Now picture for just a moment what it would actually be like to stand on Pluto's surface, because the details are almost hard to imagine otherwise. The sun would still be visible, but only as an intensely bright point of light, smaller than a pinhead held at arm's length, giving off no real warmth. You could look directly at it without any discomfort at all. The sky around it would sit in a permanent grayish-blue gloom, thick with haze, never fully day and never fully night. The ground beneath your feet would not behave anything, like ice does on Earth. At nearly 400 degrees below zero, water ice stops being slippery and instead behaves closer to solid rock, hard enough to ring almost like metal if struck. And overhead, fixed permanently in the same spot in the sky, Karen would hang there, unmoving. The two worlds are close enough in size that they don't orbit each other the way Earth orbits its own moon. Instead, they orbit a shared point in empty space between them, locked so tightly that each one always shows exactly the same face to the other, a silent standoff that has been running for billions of years. The surface itself holds its own separate mysteries. In a region researchers named Tartarus Dorsa, New Horizons, photographed something no spacecraft had ever documented anywhere else in the solar system. Tall rows of jagged ice blades, some reaching more than 1,500 feet high, made of frozen methane and arranged in long parallel ridges. A 2025 analysis of the original New Horizons data suggests these towering ice blades may wrap around as much as 60% of Pluto's equator, forming an entire ring of jagged frozen terrain circling the dwarf planet. South of that famous pale, heart-shaped plain, two enormous isolated peaks rise out of the surrounding landscape, and researchers still cannot fully explain them. One stands roughly 13,000 feet tall. The other may reach close to 20,000 feet, with a base wide enough to rival some of the largest volcanoes here on Earth. Both mountains have deep depressions at their summits, ringed by fractures with lumpy, uneven flanks that closely resemble cooled lava flows. Except, of course, there's no molten rock on Pluto. If these features are what they appear to be, they are cryovolcanoes, structures that once erupted, not with melted stone, but with a thick slurry of water, ammonia, and methane forced upward from somewhere deep beneath the icy crust. That internal warmth leads directly to one of the most debated ideas surrounding Pluto today, the possibility of a hidden ocean buried roughly 100 miles beneath the surface, kept in a liquid state by the slow radioactive decay of elements inside Pluto's rocky core. The evidence for this is not a photograph, it's a pattern. Cracks and ridges across the surface line up in ways that fit what you would expect from a subsurface layer of liquid water, shifting slowly beneath the crust. And that famous heart-shaped plane sits directly above what appears to be a positive gravity anomaly, a spot where something denser than the surrounding ice may be concentrated underneath. Similar hidden oceans are already strongly suspected beneath the icy surfaces of Europa, one of Jupiter's large moons, and Enceladus, one of Saturn's smaller moons. If a body as small and as cold as Pluto turns out to be, hiding something similar, it would suggest that buried oceans might be a far more common feature of icy worlds throughout the outer solar system than scientists previously assumed. Right now, there is no way to confirm any of this directly. There's currently no funded mission planning to send a probe back to Pluto, largely because the journey alone would take the better part of a decade, and outer solar system exploration has rarely been treated as a funding priority. For the time being, Webb remains our only working tool, quietly checking back in every few months whenever Pluto swings back into its field of view, adding another data point each time, and almost always making the overall picture stranger than it was before. Here's the detail that tends to stick with people longest after they hear this whole story. Pluto is not unique simply because of its location. It sits inside the Kuiper Belt, a vast ring of icy debris beyond the orbit of Neptune, home to hundreds of thousands of objects wider than 60 miles, along with an estimated trillion or more comets. A handful of other bodies out there, including Eris and Makemake, come reasonably close to Pluto's size. And unlike the much more familiar asteroid belt sitting between Mars and Jupiter, the Kuiper Belt remains almost entirely unexplored territory. Only one spacecraft, New Horizons, has ever ventured deep enough into that region to closely photograph any of its larger residents. And even that mission only managed close flybys of two objects, Pluto and a much smaller, more distant body nicknamed Arrokoth. If Pluto is genuinely cooling its own sky, slowly bleeding its atmosphere onto a companion moon, and possibly hiding a liquid ocean beneath a shell of solid ice, there is no obvious reason to assume it's the only object out there doing anything like this. It's simply the one close enough and bright enough for our current instruments to study in real detail. Nearly everything else scattered across that same enormous region of space remains almost entirely unobserved. So what does all of this actually add up to? Pluto was never really the dead end of the solar system that a single vote in 2006 made it seem like. It turned out to be the beginning of a whole set of new questions that scientists are still learning how to properly ask. Out past the orbit of Neptune, in the cold and the dark, there are trillions of other worlds we have barely glanced at, let alone studied closely. And if one small, formerly dismissed dwarf planet was hiding this much complexity underneath its surface, using nothing but a telescope that was never even sent there, it's genuinely worth wondering what all of those other distant worlds might be hiding too. If stories like this one, grounded in real, published research rather than exaggerated headlines, are what you want more of. Subscribe to this channel and turn on notifications, because Webb is still pointing back at Pluto every few months, and there's a real chance the next round of data adds another genuinely strange piece to this puzzle. Thanks for watching, and I'll see you in the next one.